Welcome to the Smarter Balanced Assessment Consortium's Mathematics Content Specifications, Item Specifications, and Depth of Knowledge training module. This training module focuses on three main topics. First, this module provides an overview of the structure of the Common Core State Standards for Mathematics, the Smarter Balanced Mathematics Content Specifications, and the Smarter Balanced Mathematics Item Specifications. A description of how these documents are used by item writers to write high-quality test items and tasks is also provided. Finally, this module provides an introduction to the depth of knowledge taxonomy for cognitive complexity. Let's begin with an overview of the structure of each resource document. As will be explored in greater detail in this module, the Common Core State Standards provided the foundation for the Smarter Balanced Content Specifications. The content specifications were then used to inform the development of the Smarter Balanced Item Specifications. Item and task writers are expected to use all three documents to guide the development of Smarter Balanced items and tasks. The Smarter Balanced Assessment Consortium's Math Content Specifications and Item Specifications are based on the Common Core State Standards for Mathematics. The development of these standards began with research-based learning progressions detailing what is known today about how students' mathematical knowledge, skill, and understanding develop over time. The standards are internationally benchmarked and are more focused and coherent to address the problem of a mathematics curriculum that is a mile wide and an inch deep. The mathematics standards are comprised of the Standards for Mathematical Practice and the Standards for Mathematical Content. The Standards for Mathematical Practice identify the important processes and proficiencies that students should develop. The Standards for Mathematical Content set grade-specific expectations for what students should understand and be able to do. The Common Core State Standards for Mathematics are organized into three levels. Standards, which define what students should understand and be able to do, clusters, which are groups of related standards, and domains or conceptual categories, which are larger groups of related standards. Standards from different domains may sometimes be closely related. The Smarter Balanced Assessment Consortium Mathematics Content Specifications describe the consortium's current specification of critically important claims about student learning that are derived from the Common Core State Standards for Mathematics. Item writers must write items and tasks that align to these claims and assessment targets. The Introduction and Background section presents a discussion of several issues that influenced the development of the content specifications. For example, the Smarter Balanced Consortium is utilizing evidence-centered design methodologies to create its assessment program. The General Considerations section contains discussions of four topics: how to use various types of items and tasks to connect content and practice, focus and coherence in mathematics, judicious coverage of the Common Core State Standards for Mathematics, and strategic uses of technology. The four claims identified in the mathematics content specifications serve as the foundation for the item and task specifications. Each claim is a summary statement about the knowledge and skills students will be expected to demonstrate on the assessment related to a particular aspect of the Common Core State Standards for Mathematics. Each claim is accompanied by a set of assessment targets that provide more detail about the range of content and depth of knowledge levels. The assessment targets are intended to support the development of high-quality items and tasks that contribute evidence to the claims. The content specifications also include a discussion of cognitive rigor. The Smarter Balanced Consortium is using a cognitive rigor matrix that is based on Bloom's revised taxonomy of educational objectives and Webb's depth of knowledge levels. Smarter Balanced items and tasks will elicit evidence that students have the ability to integrate knowledge and skills across multiple assessment targets and are ready to meet the challenges of college and careers. Items and tasks must be constructed at various levels of cognitive rigor. Smarter Balanced has defined 4 levels of depth of knowledge. The first level focuses on recall and reproduction of facts and other types of information. The second level focuses on basic skills and concepts that require cognitive processes that extend beyond the recall of information. The third level focuses on strategic thinking and reasoning. The fourth and final level requires extended thinking that includes complex reasoning, planning, development, and cognition that occurs over an extended period of time. Let's take a look at a sample item for each of the 4 levels of depth of knowledge. This is a Grade 8 item that is coded to Depth of Knowledge Level 1. This item requires students to recall the rules for exponents to evaluate each expression and select the expression or expressions with a value between 0 and 1. This is a Grade 8 item that is coded to Depth of Knowledge Level 2. This item requires students to use the formula for the volume of a cylinder, as well as a basic understanding of rate, to calculate the number of minutes Jane will take to fill the water tank. This is a Grade 8 item that is coded to Depth of Knowledge Level 3. This item requires students to perform calculations in order to respond to each part. In addition, students are required to provide an explanation for each answer. This is a description for a Grade 8 performance task that is coded to Depth of Knowledge Level 4. This item requires students to use concepts of geometry, numbers and operations, and statistics to determine the best solution to a problem where all constraints cannot be satisfied at the same time. Additionally, the student must provide justifications to support reasoning. Students are expected to engage with the task for an extended period of time, up to 120 minutes. The depth of knowledge levels defined by Smarter Balanced are informed by the Cognitive Rigor Matrix. The Cognitive Rigor Matrix combines 2 common taxonomies that categorize levels of cognition and shows how the Smarter Balanced depth of knowledge categories relate to these taxonomies. Here, the concept of remembering information only relates to the first depth of knowledge level. In contrast, evaluation does not relate to either of the first 2 levels of depth of knowledge. This table, which can be found in the Smarter Balanced Content Specifications for Mathematics, is a useful aid for guiding the development of items at different depth of knowledge levels. Now let's examine the content specifications. The content specifications define how the Consortium intends to assess the Common Core State Standards for mathematics. The content specifications provide a translation between the grade-level Common Core State Standards and a content framework that was used to establish item specifications. The mathematics content specifications describe the 4 claims and provide a set of assessment targets for each claim. The first claim is Concepts and Procedures, which requires students to explain and apply mathematical concepts to interpret and carry out mathematical procedures with precision and fluency. The second claim focuses on problem solving and requires students to solve complex mathematical problems using knowledge and problem-solving strategies. Claim 3 addresses communicating reasoning and requires students to clearly and precisely construct viable arguments to support their reasoning and to critique the reasoning of others. And Claim 4 focuses on modeling and data analysis and requires students to analyze complex real-world scenarios and construct and use mathematical models to interpret and solve problems. Let's take a closer look at an example of an assessment target. The number of Claim 1 assessment targets varies across grade levels. The assessment targets for each grade level are presented in detail in the content specifications and are explored in greater detail in the grade level considerations training modules. For now, note that careful thought went into examining the progression of mathematical knowledge and skills as students progress from early elementary grades through high school and as students develop college and career readiness. This progression informed the development of each grade-level assessment target. Also note that for high school, assessment targets are established for grade 11 only and reflect the skills and knowledge students are expected to demonstrate in order to be college and career ready. To help use assessment targets to inform the development and review of items and tasks, let's take a closer look at the structure of an assessment target. This is a Claim 1 assessment target for grade 4. As described earlier, the standards are grouped into clusters. The assessment targets are organized using the same cluster headings defined in the Common Core State Standards. In this example, Target A falls under the domain Operations and Algebraic Thinking. Depending on the grade level, there may be one or more assessment targets for each domain or conceptual category. Each assessment target is labeled with a letter. This example shows Target A. Recognizing the design principles of focus and coherence in the standards as a whole, not all content is emphasized equally in the standards for mathematical content. The standards communicate this emphasis through the use of domain names that vary across the grades and through the progressions that point to the major work of each grade. The mathematics content specifications identify assessment targets that point to the major work of each grade with an M and other assessment targets as S for supporting and A for additional. Evidence for Claim 1 will strongly focus on the major clusters and take into account ways in which the standards tie supporting clusters to the major work of each grade. Next, a descriptive title of the assessment target is provided. In this example, the title is Use the 4 operations with whole numbers to solve problems. The depth of knowledge level to which items and tasks that measure the assessment target are to be written is indicated. In this case, items and tasks that measure 4th grade Target A should tap Level 1 and Level 2 depths of knowledge. Finally, a full description of the assessment target is provided. The description provides details on the mathematical concepts, skills, and knowledge required by the assessment target and describes the types of mathematical content and problems students are expected to work with and complete successfully. Let's take a few moments to look briefly at the assessment targets for Claim 1 for each grade level. A full description of each target can be found in the content specifications. There are 11 assessment targets specified for Grade 3. The first 4 targets are classified under the Operations and Algebraic Thinking domain. A single target falls within Number and Operations Base 10. Similarly, one target falls under the Numbers and Operations Fractions domain. The 4 targets are within the Measurement and Data domain, and one target falls within Geometry. For Grade 4, there are 12 assessment targets. The first 5 targets are classified under the Operations and Algebraic Thinking domain. 3 targets fall within Number and Operations Fractions. Under the Measurement and Data domain, there are 3 targets, and a single target falls within the Geometry domain. For Grade 5, there are 11 assessment targets. The first 2 targets are classified under the Operations and Algebraic Thinking domain. 2 targets fall within Number and Operations Base 10. 2 targets also fall within Number and Operations Fractions. There are 3 targets within the Measurement and Data domain, and 2 targets fall within Geometry. For Grade 6, there are 10 assessment targets. The first target is classified under the Ratios and Proportional Relationships domain. 3 targets fall within the Number Systems domain. The Expressions and Equations domain contains 3 targets. A single factor is specified for the Geometry domain, and 2 targets are specified for Statistics and Probability. For Grade 7, there are 9 assessment targets. The first target is classified under the Ratios and Proportional Relationships domain. 1 target falls within the Number System domain. 2 targets are specified for Expressions and Equations. The Geometry domain contains 2 targets, and there are 3 targets specified for Statistics and Probability. For Grade 8, there are 10 assessment targets. The first target is classified under the number systems domain. 3 targets fall within expressions and equations. 2 targets are specified for functions. For geometry, 3 targets are specified, and for statistics and probability, there is 1 target. Finally, for grade 11, there are 16 assessment targets. The first 3 targets are classified under the number and quantity conceptual category. 7 targets fall within algebra. For the functions conceptual category, there are 4 targets specified. There is 1 target specified for geometry. Finally, there is 1 target specified for statistics and probability. Participants should spend time reviewing the assessment targets for the grade levels for which they will be developing or reviewing items and tasks. Now that the assessment targets for Claim 1 have been briefly presented for each grade level, let's shift our focus to Claims 2 through 4. Unlike the Claim 1 assessment targets that are drawn from the grade level standards for mathematical content, the assessment targets for Claims 2, 3, and 4 are drawn from the standards for mathematical practice that are identical across grade levels. A general set of assessment targets is provided in the content specifications and can be used as guidance for the development of item and task specifications for all grade levels. Let's look at the assessment targets for Claims 2, 3, and 4. Claim 2 focuses on problem solving. The purpose of this claim is to elicit evidence that students can solve a range of complex, well-posed problems in pure and applied mathematics and can make productive use of knowledge and problem-solving strategies. Items and tasks written to assessment targets for this claim will ask students to apply mathematics to solve well-posed problems arising in everyday life, select and use tools strategically, interpret results in the context of a situation, and identify important quantities in practical situations and to map their relationships. Items and tasks written for Claim 2 will provide evidence for several of the Claim 2 assessment targets. Each target should not lead to a separate task. It is in using content from different areas, including work studied in earlier grades, that students demonstrate their problem-solving proficiency. Claim 3 focuses on communicating reasoning. The purpose of this claim is to elicit evidence that students can clearly and precisely construct viable arguments to support their own reasoning and to critique the reasoning of others. Items and tasks written for this claim will ask students to explain his or her reasoning, justify a conjecture, and assess the validity of a claim. The Claim 3 targets require students to test propositions or conjectures, construct chains of reasoning that justify or refute propositions or conjectures, state logical assumptions that are made, use techniques of breaking arguments into cases, distinguish correct logic and flawed reasoning and explain what it is, base arguments on concrete reference, and determine conditions under which an argument does and does not apply. Items and tasks written for Claim 3 will provide evidence for several of the Claim 3 assessment targets. Each target should not lead to a separate task. Tasks generating evidence for Claim 3 in a given grade will draw upon knowledge and skills articulated in the standards in that same grade with strong emphasis on the major work of the grade. Claim 4 focuses on modeling and data analysis. Claim 4 requires extended response items and performance tasks that elicit evidence that students can analyze complex real-world scenarios and can construct and use mathematical models to interpret and solve problems. Items and tasks written for this claim will ask students to investigate problems that have more than one solution pathway, summarize the results within the context of the problem, and evaluate the solution within the context of the problem. The assessment targets associated with Claim 4 require students to apply mathematics to solve problems arising in everyday life, construct chains of reasoning to justify mathematical models used, interpretations made, and solutions proposed for complex problems, state logical assumptions that are made, Interpret results in the context of a situation. Analyze the adequacy of and make improvements to an existing model or develop a mathematical model of a real phenomenon. Identify important quantities in a practical situation and map their relationships. And identify, analyze, and synthesize relevant resources to pose or solve problems. Items and tasks written for Claim 4 will provide evidence for several of the Claim 4 assessment targets. Each target should not lead to a separate task. Tasks generating evidence for Claim 4 in a given grade will draw upon knowledge and skills articulated in the progression of standards up to that grade, with strong emphasis on the major work of the grades. Now let's shift our focus from the claims and assessment targets specified in the content specifications to the additional information presented in the item specifications. The Smarter Balanced Assessment Consortium Mathematics Item and Task Specifications are a bridge between the mathematics content specifications and the summative assessments. The item specifications further define each claim and assessment target in the content specifications by identifying evidence statements for each target. Each evidence statement has one or more associated task models. The task model describes how an item that fits the evidence statement and thus the assessment target are to be constructed. Sample items are provided as additional guidance for item and task writers. The sample items illustrate how the task models can be operationalized in an assessment item. A glossary of terms has also been provided. Let's explore the item and task specifications in more detail. The item and task specifications contain a large number of item specification tables. Each table focuses on a specific claim and assessment target or targets, and presents information that is used to guide the writing of items and tasks that collect evidence about that claim and assessment target. Let's take a moment to examine several key parts of an item specification table. The top portion of a table indicates the grade, claim, and assessment target addressed by the table. In this example, the grade is 3 and the table addresses Claim 1, assessment target A. The first row restates the claim. The second row states the content domain. The third row indicates the assessment target. And the fourth row indicates which standards are associated with the assessment target. All of this information is based on information provided in the content specifications. The fifth row indicates the depth of knowledge level at which the assessment target can be assessed. In this example, Level 1 and Level 2 are both accessible. The sixth row provides detailed information about the type of evidence required to support the claim about the assessment target. This information is useful for informing the contents of the prompt developed to elicit evidence from students. The seventh row indicates the item types that can be used to elicit evidence from students. In this example, selected response, constructed response, and technology-enhanced items are deemed appropriate. Next, task models describe the characteristics of items and tasks that may be used to collect evidence. There will be more information about task models in a few moments. The ninth row provides information about the types of stimulus materials that should accompany the item. In this example, arrays or equal group models are expected to be presented with the item prompt. The 10th row details vocabulary that is associated with the assessment target and which can be used as part of the item's content. This section provides guidance for making decisions about whether or not a term might introduce bias. Any term listed in this section is deemed appropriate for use within the context of the items or tasks developed for the claim and assessment target. The 11th row indicates which tools, if any, can be used while working on the item or to produce responses for the item. This information is intended to support decisions about potential accommodations and about resources that should be available to students as they work on this item. Next, information about any specific attributes of the item are provided. In this example, it is stated that numbers used in problems must be less than or equal to 100. The 13th row identifies any non-targeted knowledge or skills that may be required to respond to items based on the task models. Any accessibility concerns that are specific to any of the task models is then documented. This information is used to help inform decisions about accommodations for the item or tasks built from the task model. Finally, if a sample item exists, the next section will provide a link to it. Sample items provide models for what an item or task might look like. With that overview of an item specification table, let's take a closer look at an evidence statement. This is an evidence statement for Grade 5, Claim 1, Assessment Target C, which focuses on understanding the place value system. The evidence statement identifies one piece of evidence required for this claim, an assessment target. Specifically, students must be able to explain the pattern in the number of zeros in a product when multiplying a number by a power of 10. Evidence statements are used to inform the types and content of responses collected from students through an item or task and provide a foundation for developing task models. A task model describes key features and characteristics of items or tasks that are designed to elicit a specific type of evidence for a given assessment target and claim. This is a task model for the evidence statement just discussed. The task model begins by specifying a constructed response item and indicates that the item should require students to apply knowledge and skills at a level 1 or 2 depth of knowledge. The task model then describes the features of prompts. In this example, the prompt is expected to ask students to explain patterns in the number of zeros of a product when multiplying a number by a power of 10. Next, information about stimuli that are to accompany the prompt is provided. In this example, the stimuli are expected to contain multiplication problems involving powers of 10. For many evidence statements, more than one task model might be specified. In this example, a second prompt and stimuli are described, which in this case focuses on quotients rather than products. One expectation of some items written for the consortium is that the item will assess multiple claims and assessment targets. This is particularly true for items written for claims 2, 3, and 4. This is also true for certain item types, such as extended response items and performance tasks. As an example, this item table is for a Grade 7 constructed response item. For this item, the primary claim addressed by the item is Claim 2, which focuses on problem solving. This item also provides information about Claim 1, which focuses on concepts and procedures. When items or tasks address more than one claim or more than one target within a claim, the claims and assessment targets should be identified in order of importance with regards to the item. As this module has explored, the Common Core State Standards provide a foundation for defining the claims and assessment targets that are the focus of the Smarter Balanced Assessment System. The content specifications were developed by Smarter Balanced to provide a formal definition of the claims and assessment targets and provide a foundation for item specifications. In addition, the content specifications indicate the depth of knowledge that students are expected to demonstrate for a given assessment target. The item and task specifications were also developed by Smarter Balanced to define the evidence to be elicited from students to support claims about assessment targets and present task models that inform the development of items that are used to collect that evidence. Collectively, this information is used to guide the development of items and tasks that form the Smarter Balanced Assessment System. To support the development of high-quality items and tasks, item writers need to be familiar with the content and item specifications and are expected to reference them regularly when developing items and tasks.